So this is some ideas I have about making houses more efficient with the amount of material they use and stronger in many ways, so they can become both more environmentally friendly and safer. Well, to start off the list, let's begin with solar panels being built as structural components of the actual whole design. Solar panels are now do have some structural ability. For example, silicon solar panels have about the strength of glass. But we're also developing new ceramic solar panels, perovskites, which are a type of ceramic Ceramics are kind of a weird thing to define. And they will be even lighter weight and stronger potentially than some of the new ones. Now, if we use them also support some of the structure of the building, you can put them in more places without it being as lost because you're getting rid of some other material. And that could also mean you can have more power for the whole house and the grid. So you can kind of measure it. Now, they don't also have to be the strongest if they can redistribute the weight so the more the house is taking some weight. There's less of one big point of failure where the whole house is brought down if one place has a crack or something, or you can take out something and replace it more. Just a quick idea. Now, no one has also really tried to make solar panels that strong. So if no one has really tried, who knows how hard could we make solar panels potentially a lot stronger if we made them a lot more structural. For example, if you press materials together, they can sometimes become more dense and much more strong. Certain crystal structures can make something a lot more strong. Another one is you could potentially make it, if this is a building material, maybe the high efficiency, you can make it, so with solar panels, the thicker you make them, to some extent, the less efficient they become, and there comes a point when it doesn't really make sense to make them thicker, because if you make them extra thick, they stop absorbing more light. Light has already been all absorbed. But this could also potentially open up for reason to make them multi-band gap or have different layers to make them thicker to each absorb a wider spectrum of light. And that could make them build up more efficient than a silicon solar cell. Right now, they're a lot more expensive, so it's not really useful. It's useful to have more area. But this will mean, if they're structural, you get rid of some of that cost, as they are also getting rid of other material. And also, you can save more space, have more of them in the city or local nearby your building, so you also have less loss of power transmission and stuff like that. Just some ideas to put out there. Another way you can make it is some solar panels also can store electricity, and those ones can be much more thick because they have like stuff inside of them. Another one that could be useful is if the pipes that we make in buildings we make extra strong, and we figure out the piping to support some of the weight of the building. CNT solar panels we might add carbon nanomaterials, like carbon nanotubes, the strongest nanomaterial, because they can really increase the absorptivity of solar panels, so they can absorb more light a wider range away, and they can also make how electricity flows through them a lot better. So that could potentially really revolutionize the strength of these panels. Another one, getting back to it, is the pipes in the building that deliver water and stuff like that. Water is very, very important in buildings, of course, and other things. Air also goes through pipes a little bit in buildings sometimes. But pipes usually not look at support beams, but they could become support beams in themselves. And when you can get rid of some of the piping and stuff and make them extra strong, and even maybe the water helps support the structure a little bit. Well, they can't guarantee because sometimes the pipes might be empty. And then also you can make the pipes extra thick so they don't burst in winter. Something that could potentially do this a lot better is, again, carbon nanomaterial composites or composite pipes. With looking at some ideas like C2CNT and stuff, I think that carbon nanomaterials will become cheaper and affordable for this. Along a similar, so that's That structure part. Along a very, very similar line is structural wires, I'm going to call them. And these are wires that will be made with made a lot thicker, and they can carry more. Because they're a lot thicker, they can actually carry a lot more to do less loss and be less dangerous. But that would also mean that if you have metals like this, that they could also support maybe more weight. And I'm talking about really thick beams and wires carrying electricity throughout the whole structure. Or you can make the wiring more simple, where we just use less material wiring. CNT composites again could do this, because CNT composites again are a lot stronger and a lot more lightweight, so huge potential weight there. And also it could reduce the environmental impact, because the ways I'm talking about actually use CO2 from the air in the carbon step process, or C2C2. Another idea we have would be to use AI to design stuff to figure out where to best place everything together inside. And we're already using AI to design better pistons and stuff in internal combustion engines that are a lot stronger on a variety of temperatures and conditions and stuff like that. We're using it in spaceships and stuff like that. And we can do this in a variety of methods. One method that has been done that is kind of revolutionary. Well, there's two ways we can do it. And then we can do it more complex ways. One way is we build a model and we slowly chip away at stuff. And we figure out what parts of the model are taking the least amount of stress, or how the stress is distributed, and we chip away at that until that place has less stuff there. Another way around this is that instead of chipping away, we do the opposite, we add stuff where there's more stress. Then we can have genetic algorithms where we try out different variety of things. So we slowly mutate it. We do what we call mutations. We add more, or we just randomly get rid of stuff or add stuff, or we combine different models. So you may have 4 different models that work the best, and we combine them in different ways, like evolution, to figure out the best one. And then we have also like having now we have AIs with the artificial intelligence that also can look at models. You can build many models, and we can learn what works and what doesn't work. Then you have also like this better engineering computation to figure out stresses and how they distribute, and we can combine all these models together. Very much. Another idea that's a little bit more out there is to use trees to support the axial structure. Now that's probably not going to work very well in most cases, but I'm just putting out a bunch of ideas. And it'll be very cool if you could have that, to say the least. That's probably a very niche use for like to promote a really small scale project. Another way we could save materials potentially is we could use scraps from machining to make support blocks. We use the scraps from machining on site or off site to make support blocks filled up with the scraps, like a brick or something. The problem is that there's a wide range of material that's going to go into them, so it's really hard to calculate strength. So you're going to have to figure out some good non-destructive testing, or use a wide range margin for the strength, or both. Or we're going to have to fuse them together. Another one is we can use this material to make insulation. This is not the best insulation. It'll be very cheap to make. And the more insulation you have, the better your stuff is insulated. Or we just use it to make new materials in some other way. We can also use the scraps and not use it directly as much to fill out something to make materials, but we can just use it to recycle it straight up more, figure out better recycling methods, or we can feed it some of the scraps if they're organic to fungi and stuff that grows and uses that itself to either become fertilizer for plants or to make fungal structures that we can make blocks and insulation and stuff out of. So kind of a bunch of ideas there. And to even add on to these ideas a little more, what about a smart vacuum cleanup thing on site that picks up sawdust in one bin, picks up metal dust in another bin, or something as we're constructing it, and source it out, so then we can better process it for various different types of recycling much later. And the whole idea is if we can process it better for recycling much later, everything will go better. Now, how you could also have in the vacuum cleaner, not only is it vacuum clean stuff, would maintain a clean environment, which will be safer for workers and other people around potentially. You have it also separated inside with magnets or electrical currents, different metal versus non-metal, different density separations, with air filters that centrifuge stuff out based on density, and you can have cameras and stuff to sense it, along with touch sensors and multispectral cameras that go beyond just the regular wavelength of lights and metal detectors. So a huge amount of potential just right there. Also, just train people to recycle to do this stuff better and cleaner. Another way we could eliminate some of this waste material and stuff like that, and cooling and stuff, is I was thinking about phase changing materials for heating and cooling insulation. And they made said something that phase changing materials are materials that change from solid to liquid, liquid to solid, or another thing from, because there's also gas is a phase and blah blah, and all these other phases. But they can store a ton of heat compared to something that doesn't change phase. So they can heat up during part of the day and cool down during part of the day, maintaining a more constant temperature. The problem with normal phase changing material is that temperature which they change phase is constant, so it always tries to maintain like either a fixed temperature, but you might want to change the amount of heat in the house up and down very much. So how do you fix this problem? Well, you can actually change the different temperature points by adding more pressure or removing pressure, for one example. And these phase changing materials could be used as a smart insulation. The thing is, different mixes of materials have different phase points, so you can mix materials in and out together to change the phases. Or you can make it have different structures by applying liquids, by applying electrical currents to it, changing the phases slightly. This is actually used in liquid crystal display, a totally different technology. Another thing that could be done to make this whole industry much more sustainable is agroforestry. So what agroforestry basically is that you grow trees for either fruits or something, or you grow trees in between plants that you're growing. And these trees can save the plant, which can trap more moisture, make a cool, better environment for growing. And they can also attract more pollinators and more useful creatures and critters, while also not really taking up much more land. Now, you might say, oh, they block out some of the light, but a lot of plants actually grow better than partial shade. And they can also protect plants and stuff from bad winds. Now, what if you use agroforestry instead to actually grow wood, to make wood more sustainable, and the trees also prevent erosion and stuff like that. So maybe you can make one, and then you also don't have to cut down forests and stuff as much. Another thing that we can make as more of a structural component is radiators for cooling this whole thing. Could become much more strong and everything, and maybe it can become a structural component of the whole building. Another kind of idea along this whole line is to make pipes in the middle stronger, and having stronger pipes in the middle of the building. So having pipes in the middle of the building, like a column, like a Roman column, can support much more weight than having everything in the walls. Because what happens is the roof then has a weak part in the middle of the roof where there's no support. So splitting out the support can make the whole thing much stronger. So that's an idea right there. And the AI designing from before and everything could actually really make this whole idea a lot better. So, And these pipes could also, if you make them thicker, you have the other things like the wires and everything, also including ducts. Beyond that, that could also mean that you need less walls. So if you have less walls, you can have more of an open space and have an open floor plan that might be easier to navigate or clean up for a wide variety of people. The problem with an open floor plan, though, is it also has more spaces. Like if there's a lot of stuff in the middle, it might be for someone that doesn't pay attention as well, more easy for them to pump into stuff and hurt themselves. But if you have eye troubles, skin troubles, if you have ADHD or executive function or dissociate, this actually can be a real issue. And I bumped into very obvious things. So, but then again, you also have more open floor space that might be easier for you to navigate with a wheelchair, or you might have less. So like it's complex and something that most needs to be thought about very much in that incident. So another thing we could do is we could use radiators to cool off this whole thing. Oh, sorry. This apartment complex is actually a lot more material efficient in many ways and energy efficient, because you can share walls in between apartments, which means less material than separate apartments and houses. The cellular structure of it with different cells makes it more durable to like hurricane, all these other earthquake damage and stuff like that. You also need less energy to cool because the outer apartments access insulation from more inner ones. And pumping can be made more efficient, and electrical construction. So yes, apartment complexes or complexes with shared walls could be the future of saving energy in many ways, while reducing material usage. So another thing we could look at is joint and vibration houses of buildings. So this is going to sound a little weird, but stuff vibrates at different frequencies. And that can either damage something more by tearing something apart, or lower the vibration so there's less damage from the vibrations. Also, being flexible instead of rigid can sometimes mean that energy disperses without the material instead of just building up and cracking. We use this in really tall skyscraper buildings, and tall skyscraper building bridges and stuff. Not enough, but we do use it. And sometimes we actually incorporate extra stuff that vibrates in certain ways to do it. I can do this through joints or having different materials of different densities or different weights or different vibration modes attached together. This, normally you would say this wouldn't really affect a small building that much, but maybe over the long run it could prevent cracks from propagating the stress over the very, very long run, making buildings last tens or more years, or have to be repaired less. It might also become more and more important the bigger a building is. And it's more important during natural disasters, which really happen. When they happen, they're a huge deal, so you should calculate them in. So, another idea is to build sensors in the house to figure out better when stuff actually happens to start breaking down. This is more of a warning method than anything else, but that is something that should be included, in my opinion. There's a bunch of ways sensors, some things, if they're stretched or pulled or gain structural damage, the electrical conductivity changes, or the frequency of electricity, the capacitance changes, which has to do with the frequency of electricity they can switch back and forth between. Other times, magnetic properties can be made to change, the colors can be made to change. You can also put vibrations slightly through the house and see how the house vibrates, like an ultrasonic sensor to map out the house. This was stuff like penetrating radar and stuff like that. So a wide variety of stuff there. Also, better controlling the humidity of the house just throughout could potentially make the house last longer and less likely to have mold issues and stuff. And you could do humidity stuff with much more advanced sensors than we currently have. Or you can try getting more better, have less humidity in certain places and more controlled, by making some places more hydrophobic, stuff can get this less on it. So, some more ideas is the usual way we make stuff waterproof and fireproof is we fluorinate it. Now we can also brominate it and chlorinate it. Fluorine works the best, but is the most toxic and hardest to decay usually. And also the process to get it is oftentimes can release stuff that damages the ozone layer. Chlorine and bromine have the same problems, but less so, but they're less good at suppressing fires and making stuff waterproof. Now, sulfonated stuff and phosphonated stuff are a potential difference when instead of adding fluorine or like bromine or chlorine, we add sulfur or phosphorus. Sulfonate, so sulfur with some oxygen attached, or phosphorus with some oxygen attached. Now sometimes this can actually make something more hydrophilic, so you have to be careful. But they do repress flames often because they replace where oxygen can attack much more. So now oxygen can attack as well. You can even make fire, and these ones can be a lot. And you also have nitrated, rarely, but usually actually does the exact opposite. It makes it more explosive. But you can use this to potentially put in also oils and stuff that we coat stuff with, and they become waterproof for the insulation stuff. Or materials, you can also use them in the face teasing materials. So the face teasing materials also become a fire suppressant, which would be a very, very cool, neat idea in my opinion, having face teasing materials that are also fire suppressant. This hasn't been researched too much, so it's something to research more. Now, maybe you could do the bromine and chlorine in some other parts, but there's always a toxicity issue. The production of it probably can come more environmentally friendly, but the end of the life stuff is probably where it's more of a problem. Along that line is using clay-like material to suppress fires and stuff like that. Now, you might be wondering, clay-like and ceramic materials are very good at repressing fires and are very, not only are they very good at repressing fires, they also can be used as insulators, sometimes the opposite, but they could be coated in a lot of materials to make the whole house safer while you use more materials. The reason why clays and stuff don't suppress fire is not the water from fire, is that they're already oxidized so much that they can't really burn anymore. And so they actually will just use up the heat. And they also do phase change during high temperatures, which captures some of the heat. So you also have that. Another idea, I just and you could actually make sulfonated and phosphonated clay materials, which I don't know how well you could. Another idea I forgot to mention here for making stuff more, and it was waterproof, is to make more nanostructures that repel water, and these nanostructures use the surface tension of water to make the water balls run itself. Like if you ever see a straw with its hole, water will actually sometimes just form a droplet that gets caught there instead of going down the whole straw and soaking it. So if you have a bunch of little nano spikes or structures, they can actually make water curl up on itself more and set off. That could reduce the amount of water damage in buildings, and where water is in buildings, it can find it more into the main of the house where it might be nice for breathing. So that's a little idea that's a little bit out there. So next idea is pretty novel, I think, and a little weird, and that is to mine clams or mussels or shellfish for the cells. And the reason why this would maybe work is the cells of them already a lot stronger than you would expect than a micromineral, because they have proteins and stuff that actually reinforce the structure in a complex ways that they oftentimes compared to a brick, where you have brick and mortar, and the brick is very hard or brittle, but the proteins get rid of some brittle things because they stop cracks from propagating and they make it more flexible. But it's much more complex than that. It's just a simple analogy of stopping cracks progressing because they all the splitting and laying out and they sweat out. There's also some self-healing properties. But if you get rid of the organic component, you make limestone, which is already used to build buildings. And if you get rid of the organic component even more and pressurize it, you get marble and all these other beautiful rocks that people make. So you can make all this stuff artificial. Potentially, you can also make, if you crush up into powder, you can make it, use it for a, how would I say, for insulation, and it's also flame retardant. Again, and also you can mix in a little bit of this if you're making bricks, to place some other chemicals in the bricks. So huge potential there. Now, clams and mussels and all these other shellfish also really do clean up oftentimes the water supply. So this will be very good for the environment, and you can sell them for food. So there's a whole bunch of good things. And they're also starting to go more and more extinct due to global warming and other things. So you have this whole thing. Now then you're like, oh, they're going extinct, so how will we take care of them? Well, we can make shelters for them. The problem is ozone acidification mainly. And it's pretty easy to deacidify a very enclosed small space. Not an enclosed small space. We can grow a lot of clams. These can also provide habitat for a bunch of other animals. And maybe restore some wildlife to places where they have kind of fully disappeared. There's even endangered clams that maybe you can grow. Or maybe you can move from clams to, who knows, corals, but usually corals grow very slowly, but now we have ways of actually making corals grow faster by cloning them and splitting them in weird ways. So who knows the potential there. Didn't like that, so ignore that. Another one is that problem that we have that we could get rid of is maybe we could use kelp and algae for stuff in it. Now, as a wall construction material, no, and the kelp and algae is also really important for lots of marine habitat, but it might be useful for insulation, to build insulation out of in a more environmentally sustainable way. They'll provide habitats for creatures. Also, you can make plastics out of them for a variety of uses. So maybe this kelp and algae idea is not that radical or crazy idea to really propose. You can also use oils and stuff from them to make the sulfonated flame retardants and more. So, another idea potentially that I have is for using batteries or other energy stores, and this has people come up with many ways of doing this to support the building, to make it stronger and safer and everything. Now, battery supports for it are actually trying to be proposed for electric vehicles, a variety, because it would really cut down almost on all the structural components, which can be 10 to 20% of a device. And you also, if they're supporting structure, you might want to put more in because they always support structure, now it saves weight. Now, the problem with this whole thing that I just mentioned is that batteries themselves are usually pretty expensive, and we have limited supply. But we could start engineering batteries not out of lithium, but out of other materials that are less energy dense. But they could be stronger to get rid of it, and if they're more percentage of the house, then we can make up for them not being as many of them. And we can also spread better for the environment, so you don't have the same latent limitations we have with cars and stuff like that. The other thing we can do to do it is we can try to investigate alternative technologies with like aluminum batteries and stuff like that might have other disadvantages. Maybe they don't charge up as fast, but if you have more batteries or more capacity, you don't have to charge up the whole thing as fast. Or if the discharge is slow, stuff like that. Aluminum theoretically can hold a lot more electricity and magnesium than lithium. Also a couple other metal batteries, but we're far beyond. We have a lot of kinks to work out. And yes, so that, and also if we design how to do batteries for houses, maybe it'll be more applicable to batteries for cars. But like I said, there's some very different requirements. So who knows if it will transfer back and forth. Another thing. Oh, and I have one more thing to add at the end. Another thing that could work better out is solid heat transfer things. And by this, what I mean by solid heat transfer is that CNT composites and some other metal ones transfer heat much better than can transfer heat almost nearly as well as blowing air and stuff like that. Not as or water or something like that. So if we have better solid heat transfer, we can make sure the house we might need less airs and ducts and stuff like that in the whole house, which would potentially save on weights and stuff like that and make the whole house more efficient. But particularly you have to probably carbon nanotube material composites to make it more efficient. Now I'm going to have some ideas that I forgot to put. So, something I forgot to say about radiator cooling is that radiator cooling could potentially be a lot more efficient than normal cooling for a house by AC, because we're not putting in energy to transfer heat. We're more transferring down to space potentially, where it's almost 0 degrees. It's much closer to a few degrees Kelvin, and we can transfer much more heat fast. We are making much better radiator for cooling that use radiation instead of convection. It's too slow, oftentimes pumping in and out of air, so you need to have AC to back it up. And having more of the house being a radiator, potentially with fancy radiating devices, could efficiently potentially get rid of a lot of barriers with that. We have materials that can see times radiation emit with that's a current or based on their own temperature, or you can turn them in and out. So in so they radiate inwards, or outward they radiate outwards, and they all can be somehow made structural. Actually make that 24. So kind of another idea along this whole line is to have more appliances that are actually built into the house, like a refrigerator that's built into the house, a washing machine to take off some of the weight of the house. But that might be the con of that, is then it's really hard to do any construction or refurbishing. So you really have to think about that. But maybe having a closet with that you can put in items that turn it into a refrigerator or freezer. Something more to think about. That's just out there. But yeah, I'm proposing it. So another idea that's kind of more, that's not more practical, going back to more practical, is to put more stuff lower down into stuff, so more of the pipes and everything, instead of being in the walls and stuff, and the more electrical stuff, into the floors. And that can do a bunch of things. It can make the whole house vibrate less, so it will be stronger there over the long run. It can make the whole house more stable in other ways. But it also means that the stuff above has to carry less weight. But that also works less and less well the higher you want to build a house. So something I've also previously talked about that I'm adding to this list is actually using computers in the house to cool and heat up the house. Because computers, when they do computation, they produce heat. Now, people might not, people with cloud computing can really use your computers and they could save energy. But why not also make them somewhat of a support for a house, like outer casing or something like that, so there's less space taken up. Another thing I forgot to mention, I'm a row of stuff I forgot to list down, is to make the air ducts themselves support more weight, so the whole house has to support less weight. So maybe the final one is microducts. So to some extent, making something whole, having a lot of hollow tubes increases the strength of stuff. There's a limit to when you make a big hole in something, it no longer increases the strength compared to having a bunch of little small ones. And I'm not saying having a hole in some material makes it more strong. I'm saying that it makes it more strong compared to the amount of material it's used. Sometimes hollow structures are more strong that way compared to material used. Sometimes they're more strong also because not only because of the material you used, but because they can stop cracks from propagating as much because the cracks hit one section and stop, or how the vibrations travel. And they can also be more local. If you make them small, they can be more local, so they can more locally transmit forces instead of they have to travel to instead of finding the nearest pillar to travel to. So having microducts in the right ways to transmit air and stuff throughout the house might be a lot better. The con of them is that might be a lot less easy to maintain and serviceable. So you have that problem. Also, microducts might also reduce air currents in some ways and increase it, make air currents more evenly distributed, which might help circulate air in better or different ways. And currently, this might lower the spread of diseases in some places, or allergens, or make dust settle more quickly. Or you might actually do the opposite, increase circulation so you get more fresh air for some people. All this would have to be heavily designed, but then again, as I said, AI might be the answer to helping design a ton of these things. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, so I can make this monetized to help support my disability and do more stuff. If you have any questions, comments, or suggestions, please leave in the comment section below. Also, please like the channel, subscribe to the channel, and like this video. It really does help out. And share this with friends and everything. Well, thank you very much again. Goodbye.